Hi guys, so today we're going to be talking about compound inequalities. So let's use an example first. Okay, so let's consider this. So there are two statements here. One of them is that Miss Ng teaches math and PE. The other one states that Miss Ng teaches math or PE. So if we look at this first statement where Miss Ng teaches math and PE, this statement is false. And the reason is because I don't teach PE. Okay? If we think about this other statement, though, that Miss Ng teaches math or PE, this is true because I don't have to be teaching both of these subjects. I only need to be teaching one of these subjects. And in this case, since I teach math, this statement is true. Okay? This is the same thing when we're talking about our math compound inequalities. When we have two or more inequalities that are joined by the word either and or through the symbols, this is known as a compound inequality. Okay? An and inequality is true when all parts of it are true. So for an example, something like this, where 1 is less than or equal to x, and x is less than 7, we can rewrite it as x is between 1 and 7. In order for an or inequality to be true, only one part of it has to be, right? It is true when at least one of the inequalities is true, right? So either, an example here is x is greater than 2, or x is less than or equal to -1. As long as the number fulfills one of these, for an or inequality, the statement will be true, okay? So let's take a look at this, okay? So here, 7 is greater than 3. That is true. 2 is less than 10. That is true. So in order for an and inequality to be true, it has to meet both statements. So overall, this is true. Okay? Let's look at this one. 5 is less than 10. That is true. 11 is greater than 20. That is false. In order to be true for an and inequality, both of these have to be check marks. So as a result, this is false because our second statement for our and inequality didn't end up being true. Okay, so here's our next one. -4 is less than 7. That is true. 8 is less than 2. This is false. However, because it is combined with the word or, only one of them has to be satisfied, right? And because one of them is overall, this statement is still true because only one of them had to be true. Similar to the statement that Miss Ng teaches math or PE. I teach math, I don't teach PE. However, because it's an or, as long as one of them is true, the overall statement is true. Okay, so here's the next one. 3 is greater than 6. That is false. 8 is less than 5. That is false because even though it's an or, because both of them are false, overall, this statement is false. Okay? Inequalities that use the word and, they are almost always, we can write it as a single inequality. We can rewrite it into one thing. Okay? The reason why is because this tends to show us how all of the values of x are between two numbers, right? So a good example was here. We had 1 is less than or equal to x, meaning x is bigger than 1. And we know that x is smaller than 7. What we could do is we can rewrite it and show that x, this number, is actually between 1 and 7. Okay? So here we're going to practice rewriting this. So this is an and inequality. Right? So one way we can do this is -4 is less than or equal to x, and x is less than 6. Right? So this is one way to write it. However, oftentimes we prefer for inequalities to write it on the left. So if -4 is less than or equal to x, I can rewrite it as x is greater than or equal to -4, right? If -4 is less than x, x has to be greater than or equal to -4. Okay? And so here you go. If I were to graph it, okay, so negative 4, 6, this x is greater than or equal to negative 4 is here, going to the right. X is less than or equal to 6. Okay, doesn't include 6, so open circle, going to the left. Right? And so here, and inequalities, we want where it overlaps. So oftentimes when we're graphing the solution, what it ends up looking is like this, and we shade in between. And so this shows us what we originally had, that x is between that negative 4 and 6. Okay. So I'm going to have you try this one. Can you rewrite this into 2 inequalities and then graph it? Okay, so when you split it up, you should have gotten negative 5 less than or equal to x. But since we like having x on the left side, I rewrote it. So if negative 5 is less than, that means x is greater than. So I rewrote it like this. Then I graphed it. And since this is an and inequality, we want where both of the solutions overlap. And so the part where I have the purple and green is right here between negative 5 and 9, which is what we see here. Okay? So here on this next step, now we're going to rewrite it. Okay? So here x is greater than or equal to negative 5. So that means negative 5 should be less than or equal to x. Right? And then we know that and x is also less than or equal to 10. So x is less than or equal to 10. Which means when I graph it, my answer is going to be between negative 5 and 10. Right? And we would see that if I graphed each of these separately, this is where they overlap. Okay? So let's try another one. Okay, so here 12 is greater than x. That means x is less than 12. Okay, and here since x is greater than 7, x here should be greater than 7. Or in other words, 7 is less than x. Okay? If I were to graph it, it would look something like this. If we were to graph it separately, this is where they overlap, so this is my solution set. Okay? So flip. As you can see, right, and inequalities, we want where they intersect. The graph is where the graphs of the inequalities overlap. Okay? For the or inequality, we want both parts. We want the part where it's x greater than 2, x less than negative 1. We want both sides of the graph, not where they overlap. Okay, so let's do a couple here. So here on the number line below, we want to shade in all values of x that solve the compound inequality. Okay, so here negative 3 is less than or equal to x, so negative 1 to negative 3 less than or equal to x. Oh, sorry, let's rewrite this. Right, so I want it on the right. So x, that means is greater than or equal to negative 3. So that's here. Right? Helps us a lot when we're graphing if it's on this side. Right? So if negative 3 is less than x, x is greater than negative 3. Okay. Then here, I want x is less than or equal to 5. Okay. Keep going. Because we want where it overlaps, that means my actual solution set is only here, what I have in the black, where it has both purple and blue. So my solution set graph is really just here. Okay? Let's try this one. It's nice and easy when it looks like this, because we know that x is between negative 2 and 3, so negative 2. Is a closed circle because of the equal to. The side where the 3, 1, 2, 3, is an open circle because 3 is not part of the solution. Okay? And then I shade in the middle because x is in between. Okay. When it is an or inequality, we want both sides. So we want x is less than or equal to negative 2. and we want the part here, it says 3 is less than x, or x is greater than 3. We also want this part, right? So when it's an and, we only want the overlap. For the or inequality, we want both parts. Okay, so how do we solve an inequality? That's simple. We solve it just like our equations and our single inequality, and all we have to do is combine our answer later. Okay, so let's start with this one. Okay, so 2n plus 5 is less than 9. So what I'm going to do, get rid of the plus 5 first, subtract 5. I have 2n is less than 4. Then, since this is 2 times n, I'm going to divide by 2. And here, I'm left with n is less than 2. Okay? Then it's and, what else? Okay, let's see this next one. So since this is a minus 9, I'm going to add 9 to both sides. I'm left with 7n is greater than or equal to negative 23 plus 9 is a negative 14. Then, since this is 7 times n, I'm going to divide by 7, and this gives me n is greater than or equal to negative 2. Okay. So here, I can graph it. Okay, so first I'm going to graph it separately. So I have 2 and negative 2. Okay, so n less than 2 looks like this. N is greater than or equal to negative 2 looks like this. Okay. Because this is an and inequality, I want where they overlap. So where do I have both pink and the purple? And that is right here. Okay. And so one way to rewrite my answer is that negative 2 is less than n, but n, less than or equal to n, because closed circle, and n is less than 2. So this is another way to rewrite it. Okay, let's try another one. Let's flip. Okay, so that was an example where and inequality is flipped, or into two inequalities. It can also be written as one. Okay, one thing I noticed though for students is that when they have 3 sides now, they get confused. Okay, so for some, I sometimes split it like this, so that way you can see now that there is 1, 2, 3 sides. So let's solve this. So the first thing I'm going to do is get rid of the plus 1. So I'm going to subtract 1. But remember, what you do to one side, you need to do to all of the sides. Right? So in this case now we have 3 sides, so I need to do this for all of the sides. The left, the middle, and the right. Okay. 29 minus 1 is 28. Okay. Then I'm left with 4x here. And then negative 31 minus 1 is negative 32. Okay. My symbol stays the same. Okay. Then, since this is 4 times x, I'm going to get rid of it by dividing by 4. Okay. 28 divided by 4 is 7. 4x divided by 4, so 4 divided by 4 is 1, so this leaves me with 1x. And negative 32 divided by 4 is negative 8. Because I divided by a positive number, my signs still stay the same. Okay. And so here we go. So x is between 7 and negative 8, right? So a better way to write it, because normally we like going small to bigger, right? Some students would rewrite it like this. So negative 8 is less than x, which is less than 7. Okay? And so they are both, okay, so negative 8 is a closed circle, because it's equal to. 7 is an open circle, and here I'm shading in between. Okay. So I'm going to have you do this one. This is an or inequality. So solve this one and then come back and check your answer. Okay, so this is what you should have gotten. So I'm going to start with this one. I see that I have m's on the same side, so what I'm going to do is I'm going to move it all to one side. Okay. The reason why normally we move it to the left, the reason why I moved it to the right is because this m is by itself versus this side it has something. Right, so I'm going to move it to the side by itself. Okay, when I do that, I get negative 7 is less than 7m. Then, since this is 7 times m, I'm going to divide by 7 on both sides, and I get negative 1 is less than m. Okay, and then just to rewrite it, if negative 1 is less than m is greater than negative 1. Okay, then it's or. Okay, then I work on the next one. So since this is negative 6 times m, I'm going to get rid of it by dividing by negative 6. When I do that, 36 divided by negative 6 is negative 6. However, because I divided by a negative number, what happens is that my greater than now flips to a less than. Okay? And so as a result, I end up with m is less than negative 6. So together, m is greater than negative 1 or, right, since originally it was an or m is less than negative 6. So I graphed it, m greater than negative 1, so open circle to the right, m is less than negative 6, open circle to the left. Okay. That's it for today. Have a great rest of the day. Bye, guys.